Now the question is P1, these P1 and P2, they are the two planes where P1 2x plus y minus z is equal to 3 and P2 is x plus 2y plus z is equal to 2 be two planes, then which of the following statements is or are true? The line of intersection of P1 and P2 has directions ratios this. The line this is perpendicular to the line of intersection of P1 and P2. The acute angle between P1 and P2 is 60 degree. If P3 is a plane passing through the point this and perpendicular to the line of intersection of P1 and P2, then the distance of the point this from the plane P3 is this 2 by 3. So now the most important fact is that you see that this is an interesting question. See, this is your plane, say this is your plane P1 and this is another plane, say another plane, let this be plane P2. So this is the plane, this is the line of intersection. This is the line of intersection of the two planes. This is the line of intersection of the two planes P1 and P2. So now here the equation of the plane 2x plus y minus z is equal to 3. So here the perpendicular vector n1 vector that will be equal to 2I cap plus j cap minus k cap. Here 2, 1, minus 1, they are the n1, that is the n1 vector, that is the perpendicular vector, n1 vector, this is the perpendicular vector. Suppose this P1, this is your n1 vector, perpendicular vector, and which is perpendicular to the plane. And your next is that is this is P1, and your P2, this is x plus 2y plus z is equal to 2. So your n2 vector, that is equal to I cap plus 2j cap plus k cap. This is the perpendicular n2 vector perpendicular to the plane containing this. So now this is n1 vector and n2 vector. The line of intersection of P1 has the directions ratios this. Now to find this is an interesting question. See, you to find this, what I am going to do, I am going to find out n1 vector cross n2 vector. Why? Because when I do this cross, that means a vector which will be perpendicular to the plane. See this n1 and n2, the vector will be which will be perpendicular to this plane, that is this is your plane, this is your plane. So this is your plane containing the n1 vector and n2 vector. So this is your plane, this my hand is your plane which contains this n1 vector and n2 vector. So if I cross it, these two vectors, I am going to get a vector which is perpendicular to this vector, which is perpendicular to this, and see this perpendicular is parallel to this line of intersection. This vector is perpendicular to the line of intersection. This is the technique I am going to apply. This is clear because this here 2, 1 and minus 1, they are normal n1 vector, and here 1, 2 and 1, they are the normal vector of this n2 vector. So here so if I cross it, so this my hand, this is the plane which is containing this is n1 vector and this n2 vector, and cross n1 cross n2, there will be a vector which is perpendicular to this plane, and this vector you see it is parallel to this vector. So n1 cross n2, I will get a vector which is parallel to this. When this is parallel to this, then I can find out the directions ratios. So let me do n1 cross n2. So what is the result? I cap, j cap, k cap, 2 1 minus 1 1 2 1. So here you see, if I do the cross, this will be equal to I cap, this and this, 2 minus minus 1, so this will be 3 minus j cap, here this 2 minus uh, here this and this removes. So first of all, this 1 minute, there's some, let me do it properly. So first of all, this will be equal to I cap. When this is I cap, this and this and this removes, so this will be 1 minus minus 2, that means plus 2, this will be 3 I cap minus j, and again this and this removes, so this and this removes, so this will be 2 minus minus 1, so this will be also 3, and then for k, this and this removes, so 4 minus 1, that means again 3. I am getting 3 k cap. So here you see the directions ratios are 3 minus 3 and 3. So these are the directions ratios, and but the given is 1 2 and minus 1, so this is false. So your A option is false. Your A option is false. Now I am going for the second option. Here for the second option, you see that here the line, that is for the second option, you will see that the line, I think so this is clear. And for the second option, let me first write this, that means the n1 vector cross n2 vector, the result was 3 I cap minus 3 j cap plus 3 k cap. This was your result. So now here this is the line, equation of the line. So actually the equation of the line must be by A is equal to y minus y1 by b is equal to z minus z1 by c. This is the equation of the line. So I have to arrange this according to this. So this will be your 3 common, x minus 4 by 3 by 9 is equal to minus 3 common, so this will be y minus 1 by 3 by 3, and this will be z by 3. So this comes out to be x minus 4 by 3, and this is y minus 1 by 3, this is also 9, sorry, this is also 9, so this will be minus 3, and this is z by 3. So here what do we get? These are the directions ratios of the line. That means in this, you know that this is the line and this is the b vector, and this b vector, this is equal to 3 I cap minus 3 j cap plus 3 k cap. This is the b vector. So this is the b vector. So now if it is, I have to see whether it is perpendicular to P1 to this line of intersection. This is the line. This is the line of intersection. So here I have to see whether this line is perpendicular to this. So for this, the theory is A1 A2 plus B1 B2 plus C1 C2. This will be equal to 0. So 3 plus 3 into 3, this is 9. Again 3 into 3, this is 9, and again 9, again 3 into 3, this is 9. So this comes out to be 9 3s are 18. So this is not equal to 0. So here again your B option is false. So here again your B option is false. Now I am moving to this C. So for C, again I have rubbed this. For C, that is your n1 vector cross n2 vector, that is equal to 3 I cap minus 3 j cap plus 3k cap. So here I have to find the angle. So to find the angle cos theta, this is equal to n1 vector into n2 vector. This is cos theta. So n1 vector dot n2 vector. N1 vector dot n2 vector. So here by modulus n1 vector into modulus n2 vector. So here your n1 vector is that is 2I cap plus j cap minus k cap, and your n2 vector that is again I cap plus 2j cap plus k cap. So divided by root over 2 square plus 1 square plus minus 1 the whole square, again 1 square plus 2 square plus 1 square. So this comes out to be 2 plus 2 minus 1, and this is 4 5 6 root 6, and this is also 4 5 6 root 6. So this is 4 minus 1 3, and this is 6. So this comes up a 1 by 2. So cos 60 degree. So cos theta is equal to cos 60 degree. 60 degree. Cos theta it is equal to cos 60 degree. So here theta is equal to 60 degree. So your option C is correct. Option C is correct. Your option C is correct. Now I am moving to your option D. For option D, again there is another plane, and that plane is passing through this point with this, and perpendicular to the line of intersection of P1 and P2. Perpendicular to the line of intersection this, that means let this be I take as n vector. So the equation of the plane will be, your figure is somewhat like this. Figure is somewhat, this is the plane, and here this is the point for a point, that is 4 2 minus 2, and this is the normal vector, and this normal vector is 3I cap minus 3I cap minus 3j cap plus 3 cap. This is the normal vector. So the equation of the plane as per this data, r vector minus a vector and dot n vector, that's equal to 0. So here your r vector, that is xi cap plus yj cap plus zk cap, and your a vector you're passing through this. So this is 4I cap plus 2j cap minus 2k cap, and your n vector is this. This is 3I cap minus 3j cap plus 3k cap. So this is your equation equal to 0. So this comes out to be x minus 4 I cap and y minus 2 j cap and z plus 2 k cap and 3I cap minus 3j cap plus 3k cap, and this is 0. So this comes out to be 3x minus 4 minus 3y minus 2 plus 3z plus 2 equal to 0. So this is 3x minus 12 minus 3y plus 6 plus 3z plus 6 equal to 0. So this is 3x minus 3y plus 3z 3z is equal to 0. So this again x minus y plus z is equal to 0. So this is the plane and distance from this. So for distance from this, distance formula it is equal to modulus that is 2 minus 1 plus 1 divided by root over 1 square plus minus 1 the whole square plus 1 square. So this is comes out to be 2 by, and this is root 3. So your option D is correct. Your option D is correct. So this is how we solve this question. The most interesting point here is that the most interesting point of this question is that to find the directions ratios of the line of intersection of these two planes. Line of intersection, that is the most important interesting point. So we know that here, and we know the n1 vector and n2 vector of these two normal vectors of these two planes. We know this the normal vectors of these two planes. If we cross this n1 and n2 vector, we get a vector, and that vector is parallel to the line of intersection of these two planes. This is the interesting point in this question.